So now we're going to graph a system of linear inequalities. So if we look at the first example, it says we have three linear inequalities there. I've got 2x minus y is less than 4, x is greater than or equal to 0, and y is greater than or equal to negative 2. So these two inequalities are actually just horizontal and vertical lines. So we're going to graph those first. So I'm going to graph the first one in red, x greater than 0. Now again, greater than gives me a dotted line. So I'm going to these are all the values that are greater than 0. Okay, so the x values. So I'm going to indicate that I want to shade to the right hand side because those are the x values that are greater than 0. Now looking with my blue line, I want y greater than negative 2. So I'm going to go to where y equals negative 2. Which is right here, and again I'm dealing with a horizontal line. It's a dotted line, and I want all the y values greater than negative 2. So far I'm already seeing a region where these are overlapping. You can see on the upper right hand area of the graph is where already red and blue are overlapping. So now I'm going to graph my last line in green. I've got 2x minus y is less than 4. I can put this in slope-intercept form to help myself. So I've got negative y is less than negative 2x plus 4. Now I need to isolate y, so I need to divide by a negative 1. When I divide both sides of an inequality or multiply both sides of an inequality by a negative number, I have to flip my inequality symbol. So negative 2x divided by negative 1 is going to give me positive 2x. Positive 4 divided by negative 1 is going to give me negative 4. So now I have a linear inequality that I can graph. I'm going to go to negative 4 on my x-axis. So 1, 2, 3, there's negative 4. Now I want a positive slope of 2. So up 2, right 1, up 2, right 1. And again, we just make some dots in order to give us the general idea of what our graph is going to look like. And we go back to thinking about, is my line solid or dotted? Because this is a greater than but not greater than or equal to, we're going to make this a dotted line. Okay, so the last part is to shade what side of the green line is going to make this true. And again, I'm looking to my point of 0, 0, my origin. The green line does not go through that, so we can test that point. So we're going to say, is 0 greater than 2 times 0 minus 4. Well, 2 times 0 is just 0. 0 minus 4 is going to give me negative 4. And 0 is in fact greater than negative 4. So I want to shade this side of that green line. Now I'm looking for the region where everything overlaps. And in your homework, this is especially true. You only want to shade the actual solution. So where my red shading line is going to intersect my blue shading and my green is this little region right here. So when you're graphing it, you have to graph all the inequalities, meaning the dotted lines, but then you only shade the actual solution set. So this is my solution set right here. In the next example we have below, it's a little bit of a different setup. I've got negative 2 is less than or equal to y, which is less than or equal to 4. So if I break this up, I've actually got two linear inequalities happening here. I've got negative 2 is less than or equal to y. So if I graph that one in red, I'm going to go to negative 2. Now I'm using a solid line here because of the fact that it's less than or equal to. Now y has to be greater than negative 2, so we're going to want all of these values above it. Now if I go to my next one, I've got y is less than 4, which is going to be, and this is less than or equal to 4, excuse me. So that's a horizontal line, but again, I want the y values that are less than, so I'm shading this side. So I only want to shade the solution set, which is where the red and the blue overlap, which is going to be right here. And let's erase a couple little marks that went outside that shouldn't be there. And there is my solution set there in black.